Today in this video we'll be discussing the concept of isotopy, but before we move into this concept, let us try to understand the two terms, which are atomic number and the mass number. Atomic number. Now, this atomic number now is the number of protons in the nucleus of an element. That gives you the atomic number. And this number of protons in the nucleus of an element is also known as the number of electrons. So the total number of protons in the nucleus of an element equals the number of electrons, which results to the electrical neutrality of that element. Now, this atomic number is denoted by the letter Z. And now, remember, as the number of electrons, which is equal to the number of protons in the nucleus of an element, this also determines the chemical characteristics of that element. So, the study of the chemical characteristics of an element will result to a study to the number of protons in that element. Now, let's talk about the mass number. The mass number of an element is the sum of the total number of protons and neutrons in the nucleus of that element, which also determines the physical properties, the weight of the nucleus of that element. That gives you the mass number, and that is denoted by the letter A. Now, the element is denoted by letter Z, where X is atomic number and A is your mass number. So if you have the atom of sodium like this is 23 and this is atomic number 11 and with mass number 23. Now if you have chlorine is atomic number, we have atomic number 17 and mass number 35. Chlorine is an isotope, so also chlorine is 37, 17. Alright, I believe this is understood. Now let's go straight to this isotope. What isotope is. Now when we talk about isotope, the isotopes of an element is an atom or group of atoms which possesses the same atomic number but different masses. That will give you has to do with isotopes. Atom has different number of neutrons. That results to isotope. So isotope is as a result of difference in the number of neutrons of that element. Now we also know that there are atoms which has the same mass numbers but different atomic number. Now in this case they are no longer isotopes. Now let's take for instance an example of an isotope. This is isotope chlorine. Now this is an isotope. So, but sometimes we have different atoms with the same mass number but different atomic number. Look at this. Calcium 20, potassium 19, and mass number 40. Mass number 40. Now these are two different elements, calcium and potassium, with the same mass numbers but different atomic number. In this case, what do we call this element? These are what we call isobars. These are called isobars. So different atomic number with similar mass numbers. In this case now, this one now has different chemical properties. Calcium and potassium possesses different chemical properties. But in the case of this element here, chlorine with mass number 35 and chlorine with mass number 37, but the same atomic masses. In this case now, both these two isotopes possesses similar chemical properties. Why? Because of equal number of protons, which is also the equal number of electrons, which determines the chemical properties of that element. I believe this is understood. Now let's take some calculations involving this atomic number, mass number, and the concept of isotopy. Copper with atomic number 29 has isotope 65 and isotope 63. Give their atomic composition. Now there are different ways to solve this problem, but a simpler and easiest way is to draw a table like this. Now we are asked to determine the atomic compositions, that is the composition of those atomic particles in that element, say copper 63 and 65. Now the number of protons, remember during our definition for atomic number, the atomic number is the number of protons in the nucleus of an element, and these protons equals the number of electrons. So from the question, the answer is given already, the atomic number 29. So for copper 63, atomic number is 29. And also electron is 29. Now let us now find the number of neutrons. Now this is the formula to calculate the number of neutrons. Mass number is equal to the number of neutron plus proton. This is the formula, proton. To calculate the number of neutron, we use this mass, and this gives us 34. So a number of neutron here is 34. I believe this understood. Now the number of neutron for this isotope of copper with mass number 65, that would be 65 gives us 36. So our answer here is 36. An electron here remain 29. Here also 29. Alright, so this is how to look for the atomic composition of an isotope given to you. Just use this formula and solve it. If you encounter other examples, other questions similar to this, just do it this way and you are good to go. I believe this understood. If you have any question to this, please remember to drop it in the comment. From this question, we are to calculate the relative atomic mass of magnesium with these isotopes 24, 25, and 26, and relative abundance respectively of 78.6, and this 10.1 for 25 and 11.3% for isotope 26 of that magnesium. Now, from this composition, we should calculate the relative atomic mass of magnesium. How do we do this? I hope you can see the question incomplete on the screen. Now look at how to do this. Calculating the relative atomic mass of this element. This is the simple way to do this. Remember, these are the composition of this isotope. So relative atomic mass will now be sum of percentage abundance. Alright. So this gives us the relative atomic mass. The sum of the percentage abundances times the masses gives us the relative atomic mass of this element, magnesium. Alright, now let's go ahead to compute the composition. This is the first isotope is 78.6 over 100. Remember its percentage, so you divide by 100, 78.6 over 100 times the mass. So this is 24 plus the next is 10.1 all over 100 times 25 plus the last isotope. When we input this, simplify this, multiply and then add all together, we should be getting something approximately. We should be getting 24.33 approximately. So this is now the relative atomic mass of magnesium from this composition. I believe this is well understood. You can use this to solve other examples on your researches. There are many questions which I'm going to place some on the screen for you to try them, and then come to the comment box and tell me if at all this help. If it helps, let me know. If you have any problem, please use the comment box or send me an email. I will be there to reply to you immediately. Thank you very much for watching. See you in the next